Hello again, Euro, and we're carrying on uh, our topic this week on waves and electricity. Now, we're going to be having a look today just at series and parallel circuits, what they are and what the difference is. You're going to be able to explain, hopefully, why more current can flow in a parallel circuit, and also explain how and why we use parallel circuits in homes. Now, okay, on the screen at the moment, there's a couple of circuits, and I just want you to have a quick look at them and see if you can work out, or what do you notice about these circuits. So just pause the video here, just for a couple of minutes, have a look and make a note. Now, right, hopefully you've done that. Okay, if you have a look at these circuits, we've got our cells here, then it comes around here, we've got a light, or a bulb I should say, another bulb, a switch, and then back to the cells. Here again, we've got our cell, comes around, these are bulbs, and again here, we've got our battery, or cell I should say, bulb and a bulb, and this is the circuit diagram for it. Now, all three of these circuits are in fact examples of parallel. This one here is a little bit more interesting because you'll notice there's a switch involved. Now, parallel circuits have different components. Well, okay, so different components have different branches of wire. So if we look here, it comes around, carries on to complete the circuit. The same here. Now, why do you think parallel circuits tend to be used more today than in the past? Okay, you may remember, or you may not actually, because you guys are a lot younger than me, but I always remember getting the Christmas lights out for the Christmas tree and having to spend ages going through and checking every single bulb was in properly and hadn't blown. And the reason for this was that they were wired in series, which meant that the electricity had to flow down the wire, go through the bulb, down the wire, through the next bulb, down the wire, through the next bulb, and it just followed on. Now, if one of those bulbs was broken, then the whole circuit was broken because there was no other way the electricity could continue around the circuit. Now, if we look at these, you can see that it comes round. Oh, it's broken, it can't go around, so it takes the next branch, can then go through the bulb, back up, and into the cell again. The same with this one. It just completes the circuit. Now, if we were to build both these circuits at the same time, which do you think would have the brightest bulbs? Now, this is an example of a series circuit. This is an example of a parallel circuit because there are two options or two branches that the electricity can take. Oh, sorry guys. Now, which do you think would be brighter? Yep, you are correct. They would all be the same because there is the same amount of power going to each bulb. Now, if you were to add a bulb to a parallel circuit, would they stay bright or get dimmer? And in a series circuit, if you added more bulbs, what would happen to them? Pause the video here, take 30 seconds, and just make a decision. Okay guys, so when you add bulbs to a parallel circuit, they stay bright because each of the bulbs takes the same amount of power. However, in a series circuit, each time the electricity goes through a bulb, there is less and less power, so it becomes slightly dimmer each time. Now, let's have a look at these ones here. So, if I was to take out a bulb from these circuits, what would happen to the other bulb. So the electricity is coming around the circuit, through this bulb, and back round to the cell. If this bulb was removed, what do you think would happen? Would this bulb still light up? And the same with this one. The electricity comes around here, some goes here, some goes here. If this bulb was removed, would this bulb still light up? Okay, you are hopefully correct. In a parallel circuit, this one would stay lit because the electricity has an alternative route around the circuit, whereas in the series circuit, the electricity comes around here and it can't go anywhere else, so it gets stuck. Now, if we look at this one here, okay, current in a parallel circuit. Okay, so the current comes out the cells, starts going around. Half of the current goes down into the first bulb, assuming they are the same wattage, and the other half goes down there. So if we then put an ampage amount to this, and we've got 3 bulbs in parallel here, so 6 amps comes down here. What do you reckon the current will be here? Okay, how many bulbs have we got? We've got a total of 6 amps. It's quite logical. Yep, that's correct. It will be 2 amps. How many do you think would be here? 2 again, and here. Yep, 2 amps again. And finally, what would the current be here? So if you've got 6, 2, then 2, then 2, back up to here, you're right, that's 6 amps. Okay guys, it's a bit of a whistle-stop tour for you, but hopefully it sort of makes sense. Have a go at the worksheet, well, the work booklet that you've got, and I will put a question onto Shobi as well for you. Okay guys, have fun.